Okay, so one of the tasks that you've been assigned to work on this week is to add a database to your project, right? And to use a technology called Jpa, or Java Persistence API, to be able to programmatically talk to the database. Right? So Jpa is a technology that allows you to take any Java object, any Java class, and map it to an equivalent relational database table. Anybody had a chance to play around with the Jpa before? Only a few, maybe. Okay. Anybody take 3200 database management? Okay, a few. All right. So we're going to give you all you need. There's some slides here that we're offering you. These three slides. You should go over these slides just to get a feeling for what Jpa is. I'll demonstrate here in class, and also we've provided all the source code that you need for creating the data model, creating the repository, creating the web service. So you shouldn't need to code much. You just need to get it going. You need to get it working. Remember, everything needs to be deployed on Heroku by the end of the sprint, right? Going through the appropriate software development lifecycle stages, right? Where everybody's code reviewing their code, everybody's merging, everybody is moving everything towards completion. Do not put anything on. Do not merge anything in master that is broken, that you know that has not worked well locally in your environment. First, fix it in your local environment before making sure that to push it to a higher environment. So let's take a look at Jpa. Let's see. So in the example that I shared with you in the source repository, I asked you to do a couple of configurations in your project. One of the configurations was to inside of your project there will be a file called application.properties. Right? At first that file will be empty. There will be anything inside. That allows you to configure the project, or any resources that you need to log in, or things like that. In particular, you're going to configure database access. You can configure using tokens that are very well known. These are very well known tokens to the system, right? That are used by various resources. In this case, we are, for instance, configuring the URL location of the server where it's running, that's hosting the database. We're also hosting a username and password to be able to log into that database, right? And then we have several other configurations that are Jpa specific. Right, so for instance, all of these are Jpa specific configurations. Jpa, as I mentioned earlier, Jpa stands for Java Persistence API, and allows you to create just a simple Java class, any Java class, and map the fields in that Java class and the name of the class, map it to an equivalent SQL table. Right? And so that every time you manipulate the object, creating new instances or removing the instances or manipulating an instance, you can map those changes in memory with those pointers into those objects in memory, map those changes to rows and records that are stored permanently in a database. And Jpa allows you to programmatically do this very easily. There's a couple of configurations that allow you to change the behavior. One of them is the DDL, or the data definition language, that allows you to configure Jpa to whether you want Jpa to automatically create all the tables for you. Right? It'll look at all your Java classes under a particular folder, under a particular package, and it'll map the names of the classes to a table. It'll map the fields, the variables in a class. It'll map them to fields, and you can configure whether you want it to create a database for you or not. Right? If you configure, you can specify either create here. Create means build it, create it from scratch, whereas update means create it from scratch at the beginning, but once it's created, do not destroy it. If you leave it in create, every time you start the server, it'll drop your database and it'll create a brand new. So any data that you had there that you had created previously will be gone. So you have to be careful. So create will create the database every time brand new, every time the server starts. Whereas update will create it only the first time around if it's not there already. And then subsequent times that the server starts, any changes in field names or data types or names in the classes, any changes that occur, it will try to alter the database, right, to reflect those changes in your Java classes. Yes? Right? And then there's none that basically turns off this feature. For development purposes, if you're getting started really early, if you're very early in the process, create might be a good place to start. Right, it'll create all the databases, any primary keys, any many-to-many, any mappings in the database, and perhaps at the beginning you might not care about the actual data that you're storing, right? You're just testing, you're just learning. Once the database is fairly mature, and the tables are fairly stable, you might want to change this to an update, meaning only minor updates here and there, maybe a data type here, maybe you want to change from varchar 32 size to varchar 45 size, but it's the same data type, the same name of the field. Update can do that, can alter the tables for you without dropping the entire database. Once you're in production, right? Once the database is all set and you're ready to deliver this, you would turn off this feature and you say, no, I don't want you to generate anything, especially if this is a database that has been around for a while. And you certainly don't want to modify anything that has some legacy database. You don't want to drop it, obviously, and you don't want to modify anything. You would turn it off and do the mapping yourself. A couple other things that are useful in debugging while you're developing. You can see all the SQL commands are being sent to the server. You can see all the create, inserts, updates, deletes are being sent to the server for debugging purposes. You can see exactly what Jpa is doing to interact with the database, which is very useful for debugging. But in a production environment, you would turn this off. You would comment it out or remove it altogether since you're not debugging in a production environment. Okay? All right, so that's the configuring Jpa. The other thing that you'll be asked to do is to download all those libraries that implement the Jpa the Jpa behavior, and for that you'll need to update your POM file. In your POM file, you'll need to make two dependency entries. One of them is downloading the Spring Boot's Jpa plugin, right? So that the Spring framework can talk to Jpa and use it as a main data layer to talk to a database. Yes. The other dependency is the Java SQL connector. Right, this is the driver that allows Java programs to actually talk to a database. So this is the lowest, this is the lowest level of the layer, right, that actually talks to a database. On top of that, there's a higher level, the Jpa, that allows you to just work with Java classes and forget about any low-level database communication. So you need those two. In the MySQL connector, I'm using version 8 of MySQL. This will be different versions for you, depending on the MySQL version that you might have installed locally. I'm using version 8. Okay? Any questions? All right. So for the assignment, I've asked you to create a couple of data models, depending on what team you're in. If you're in Team 1, I've asked you to create a user data model, which I've already provided the source code for. And this class used to be just a plain user class, right? There was nothing special about it. Only recently have we decorated these classes with these annotations, right? These are Jpa annotations. All the Jpa annotations live under JavaX persistence, under that package. So all these annotation entity, right? That's a Jpa annotation. What that annotation does is it says, hey, you see that class over here? Make a table out of it, right? And also the variables in that class, make them fields in the database. Map them to fields. Now by default, it'll take the name of the class and convert that into the name of the table. You can override that with the @table annotation. You can say, well, I know that by default you want to use the same identical name of the class as the name of the table. But you can override that with the table. You can format it. You can say I want to use a plural version, users, as opposed to the single case, singular. The other thing that we're annotating here is that we are adding a field called ID. And we're saying that that's going to be our unique identifier. That's going to be uniquely identify a user, right? And so it's going to be our primary key. Right, meaning this cannot repeat, right? It's going to be a unique. Also, we are delegating the generation of the value of who chooses the value of this field. We're delegating to a database as you generated. So this is an auto-generated value. So in MySQL, to generate values, you use auto increment. It starts at 1, then 2, 3, 4, and just increments from there on. Yes? And different databases do it a little slightly different. Yes? Right. So if it's null, if the ID is null, then it will auto-generate it. If you provide it, it'll choose whatever you give it. Okay. Yeah. Yeah, and actually you don't really need the constructor. It was there for just for demo purposes. The other thing that you're asked to build is a repository. So repositories are Java interfaces that provide all the basic CRUD operations, right, already for free, right? That you can create, read, update, and delete, and it creates all those for you. You don't have to build them. Only if you want to create additional interactions with the database, you can create your own. Here we've created a couple ourselves, just to give you an example. But most of what you need is already inside in the CRUD repository. And so that it'll provide functions such as find all, find by ID, delete, so save, to be able to do inserts, updates, right, or selects to the database. All right, and so this is the main mechanism that allows you to interact with the database. Another deliverable that we've asked you to do is create a user service that uses that repository to actually talk to a database, right, so that it can go and fetch all the users or fetch a particular user by ID using the functions declared in the repository. Right? So let me demo for you. For instance, you might have a first let's look at the database. Let's see what we have so far. That's section 2. Let me open section 3. In section 3, we have 3 tables: service, categories, services, and users. Right? So let's create another one just to demo this. In the models, we'll create a new file here, and we'll call it review, because we need to review a service provider, right? We need to write a review for them. So this will be a review. And this will be, I guess it didn't create a Java class. Let me delete that. So new Java class. I'll call this review. In the models. In a review, you might have maybe a private string title for the review, and maybe private string the actual review text, and we're going to create a unique identifier as an integer ID. And we'll create also all the setters and getters that go along with this. And I didn't want them under the title. Let's move them down one. There we go. All right, so up to this point, this is just a plain old Java class. There's nothing spectacular about it. But we can start annotating it, saying that I want a table, that I want this review class to be mapped to a table. By default, it'll map it to a table called review by default, because that's the name of the class. And we'll leave it like that. We'll leave it for this example. We'll just leave the default. We're also are going to declare the following field to be a primary key. And we're going to delegate to the database to auto-generate this value using the strategy of identity, which means in MySQL, it'll use auto-increment. In SQL Server, it'll use identity. And if you're using Oracle, then you probably will use a sequence, right? Where you have an auto-generated sequence. So depending on what vendor you have, you might have to change this a little bit. But I'm using MySQL, so identity generates an auto-increment. Very good. If we compile this, we go to section 3, and we go into, and we do maven clean install. This will compile, package. All right, and if we run it, let's see, jar target. And let's see, the tables. It did not create the review. Why did it not create the review? Tables. Oh, we put it in the right place. Review, yeah. Entity, ID. Let me stop this. Let's update the project. Maven update project. Let's try again. Do we put it in the right folder? I believe we did. We put it on the models. Yep. It didn't create the table again. Let me see what we have here. We have the main application. Let's run that. Run as Java. Huh. All right, let's keep going. Let's add now the repository. Oh, we don't have a repository. Yes. Oh, did I leave it none? No, this is which one is it? Is it this one? None. Oh, yeah, that would help. Thank you. Yes, so it's working the way it's supposed to. So let's do an update. And let's start this again. There it is. So you see it's spitting out the command, right, that it's using to talk to the database, right, to create that table. And by default, it uses review, the name of the class, right? And if we go here and update this, notice that review is actually there. And as part of the assignment, we ask you to copy the create statement that it was actually used for creating this table. So this is one of your deliverables, right? Not only the class, right, that we give you to the class for you. We ask you to also copy the create statement and just add it in your resources in the SQL and create a new file here, and this will be create review.sql, and then just paste that in there, right? And that will be the one of the deliverables. The other thing that you're asked to do is to create a repository for each one of your data models. Team 1 will have user, Team 2 will have services, Team 3 will have service categories. So the repository, let's build one of those. In the repository, you'll need one repository per data model. So let's create one. So this is Java class. And in this case, will be a review repository. And that repository is actually, this is actually an interface, not a class, interface. And it's going to extends a CRUD repository. And again, CRUD repository is going to implement all the lower level finders and delete and save and updates. It just needs to know what is that you want to CRUD, create, read, update, and delete. We want to CRUD reviews. So review, there it is. And also needs to know what the type of the primary key is. In this case, it's an integer. Okay? All right, we're all set over there. We also need to expose this. Another deliverable that we ask you to do is to expose this through a web service. All right, so let's create a web service for our new review. So this will be new class. It's going to be a review service. In the review service, this will be just a plain old REST controller. That should have things such as a public list, or retrieve all the reviews, find all reviews. Right? It should have what else? It should have maybe public, return a single review, find review by ID. If you give me an integer, review ID, and return one single review. In the examples from the previous assignment, the user service was using a hard-coded array of users, yes? In this case, we're going to be using the database. So to talk to a database, we're going to be using the repository. The repository is the one who has all those functions. So we're going to inject the repository in here. It's going to be the review repository. And so now we can use it to talk to a database. So for instance, we have the review repository. It has functions such as find all. Find all retrieves all the records, right, for that particular table. It's complaining because, why are you complaining? Oh, return. And I believe it returns review. Did I spell it wrong? Yes, I did. There we go. Thank you. And it returns an iterable as opposed to a list. So we're going to cast it. Let's cast that. And let's try it out. Let's run it. Let's rerun it. Oh, we never mapped it. Stop at this. We never mapped it. So let's map it to a GET request. Right? So if you ask for /API/reviews, I'll get all the reviews. Get mapping. Yes? All right, so now we can try it out. Let's run this. So if we go and hit the server, localhost 8080/API/reviews, all right, it comes back with an empty array because there are no reviews. Indeed, if we go to a database, there are no records, right? So if we go to review and do select, indeed there are no records. So let's create one. So it says maybe we had somebody come, Alice. So the title might be Alice was wonderful. Awesome. Okay, let's insert that. Another deliverable that we ask you is that all those inserts of adding some data into your database, right? Copy that and create a in your deliverable here your inserts. Create a file. So insert reviews. SQL. Paste. All right. All right. So we inserted that. If we now hit if we just hit this again, notice that now we do have that access to that data. Yes.
So automatically give it an ID form.
Yeah, because it's auto increment.
And once you have a database, can't you export it as a doc or something?
Yes, you can. Yep. Yep, you can. The whole database, yeah, sure, you can do that. Yeah, when we inserted this one, we never provided it, and it created it for us because it's using auto increment. Everybody okay? Right. The other task that you're asked to do is the find record by ID. So this might map to something like such as it's also a get mapping of API/reviews/ID, right? And then we can map it here with a path variable, and the name is ID that maps to a review ID. And then we can use the repository to return review repository to find by ID. Find by ID, and we can pass the review ID. Now it's going to complain because find by ID is a little hesitant that ID might not actually exist in the database. Yes? So it needs to be able to represent null. And so it actually returns an optional review, meaning that if the object is not there, it wants to be able to have wants to have a graceful handling of that error, that there's a null, right? So there's no null pointer exception. I'm going to be lazy, and I'm just going to retrieve the inner record that is inside of that that optional. If that ID is null, this will give me an exception, right? So obviously you would not do this in production. You would test to see whether it's null or not and whatnot. I'm just being optimistic, and I'm assuming you're giving an ID that actually exists. So I'm just getting it and unwrapping the object. So let me restart that. So if I refresh, I have that review, or notice it's an array of reviews. So here I would have all the reviews, or I can ask for a specific review if I know its ID. In this case, it's 1. It returns that one object. So if I had hundreds of reviews, I can ask for a particular review by an ID. Now this is the beginnings of a backend. Next week, in a couple of weeks from now, we'll start introducing the front end. Right? So some user interface is going to be using this API. Right, it's going to ask for the reviews, or the users, or the services, or the service categories, and they're going to receive arrays of these objects, and they're going to dynamically render some user interface. Yes, well, that's a ways out. Everybody okay? Right, we're setting up the back end of this. Any questions? Right, we give you all the code, so there's very little that you need to do to actually code. You just have to get it working. Right. Now so team 1 is going to be users, team 2 services, team 3 service categories, but then each team member is going to have different responsibilities. Like for instance, team member 1 is going to be handling the data model, meaning this part, right? Creating the data model, the object and the entity and the ID and the generated value. Yes. They're also going to be responsible. The same team member is also going to be responsible for the create statement, right? This create statement. So they're going to have to be able to, they're going to copy this and create the file. So you're going to be responsible for that. Team member number 2 is going to be responsible for the inserts, right, that we did earlier, right? Insert a couple of records there. They're also going to be responsible for implementing the repository. Okay, the repository it's not going to be as trivial. It's going to have a couple of other functionality of retrieving things using some of these queries. So that's team member number 2. Team member number 3 is going to be responsible for creating the service. Yes? Again, we gave you the source code for all the 2 types of finders: a create, an update, a delete. Yes? Right? They're also going to be responsible for creating a postman that allows them to test the find all, find one, find create user, you update user, delete user. They're going to create a collection, and they're going to share it with us. Share. All right, they're going to get the link, and they're going to copy that link, and that link you're going to submit that as a deliverable. Make sense? All right, that's your individual deliverable. Now each team also has different deliverables that are in an organization, and you have deliverables that are part of the team. Yes? The assignment captures this. If you go to assignments and assignment number 3, there's actually 3 parts to this assignment. The first part is the organization level task where 9 of you are going to collaborate to do that part. Yes? And that's going to be 20% of your individual grade. Okay, this includes creating the GitHub repository, creating the Heroku, right? Creating all the setup for the environment, deploying things. So that's the 9 of you are going to work on this part. And for the team, this is where you're going to be working together to do the sprint planning, create the boards, create the stories, add them to the Scrum board, create a backlog and create the sprint and start the sprint. Right, and you're going to have the daily Scrum meetings, 5 to 15 minutes a day, maybe an hour or so for the sprint planning, maybe today or during the weekend, to plan the sprint. So that's going to be 30% of your grade. And then what we just did with Jpa, right, creating the data model, creating the repositories, creating the service, that's going to be your individual grade, right, and that's going to be half of your grade will be part of that. Yes? All right, so we'll create a column that's going to do a weighted average of all these 3. Right, and that's going to be your final grade for assignment number 3. Make sense? Everybody okay? Awesome. Yes? So we're asking you to create, let's see, 4 Scrum boards, right? 1 for the organization. You'll have to create a filter that says, show all the issues from all 9 individuals in the project. You'll need to create a filter for that. And then Scrum boards that are individual to your particular team. So team number 1 will have all the issues for doing the users. And team number 2 will have all the issues for doing the services. And team number 3 will have all the issues for doing the service categories. Right? Again, for that, you'll need to create filters, so that you only see things that are specific to your team. The default Scrum board that gets created for you shows everybody's issues. Right? So I guess that's the organization Scrum board is already created for you. Probably you won't have to do anything to do the organization Scrum board. Okay? I believe so. I had a couple of students telling me that yes, they had those permissions. If you cannot, if you see you don't have permissions, right, you can assign it to your TA. So you'll have a TA in your team, right, and anything that you see, I don't see it, right, assign it to a TA as a task, and they'll create the dashboard or the board for you. But I believe I had some students telling me that yes, they could do it. So, verify. So verify maybe today or tomorrow. Make sure that you have the permissions. Yes.
When you try to create a Scrum
On a project. I think it asks you on a project. So it would be on a project, based on a project. Yeah, we'll look at that in a minute. Okay. So again, this is very common at the beginning of any project about permissions and who can do what and setting and talking to the system administrator about all sorts of challenges of setting everybody up. It's very, very common, right? So this is all going to be a nice learning experience on how to set up all these things and deal with operations and all the system administrators. Questions?